Going on to topic 6, this will be the last topic we cover in Math 100. And it will contain perfect square trinomials and differences of squares in sometimes their equation form. So here are the items we'll be doing. Now, if you recall, as we built up to this, we did talk about the perfect square trinomials, and let me just build that up a little bit. We said if we had something like this, a plus b, the quantity squared, or if we had a minus b, the quantity squared, that a special way of multiplying this, or in a sense, it's not really a FOIL, but a special recipe, was to take the first term and square it, multiply these two terms together, and then double it. So that would be a positive AB, and then by 2 became a positive 2AB, and then squaring the B term. And this one was pretty much exactly the same, except if the middle sign was plus, then this was plus. Here, the middle sign will be negative. So square the first term, multiply these two together. It's going to be a negative AB, double that, and that will be a negative 2AB, and then square the last term, and that gives you a plus B squared. So you see these are pretty much the same except for the middle sign, which is determined by the middle sign over here. And these are called perfect square trinomials. So if something's a perfect square trinomial, it will be factored into a binomial squared, which is like a little shortcut, if you can recognize it. So here, the first thing they're asking is to determine whether each of the following is a perfect square trinomial. Well, what are the requirements? The first term is a perfect square. The last term is a perfect square. Okay, now what's the square root of 16? 4. Double 4. 8. This is a perfect square trinomial. So this is yes. All right, this is a perfect square. This is a perfect square. And of course there's negative in the middle, but that's okay. What's the square root of 36? 6. Double it. 12. That's not what's here. So this is not a perfect square trinomial. Now for this one, you have to be careful. Is it in standard form? And the answer is no. So remember, when we go to factor, we want to put something in standard form. Now, is this a perfect square? Yes. Is this a perfect square? Yes. All right, what's the square root of this? Well, it's 5. What's the square root of that? 2. And 2 times 5 is 10, and if you double it, you get a 20. So this is a perfect square trinomial. And to factor this, we're going to take that x, put it there. We know this is going to be a plus, and the square root of that we said was 4. And that is the method by which we factor a perfect square trinomial. Then try it, square this, multiply this, double it, square that, and it checks out. And for this one, the square root of that is 5x. The square root of the 4 is 2. And we need a negative sign in the middle. So square this, you get the 25. Multiply these two together, you get a negative 10x. Double it, you get a negative 20x. Now, for those folks in Math 105, we're going to use this technique in the future, so it is a technique you should try to master. Okay, let's go on. And they're going through the protocol. In letter B, they're perfect squares, but the square root of this does not add up to that, so it's not. And again, write it in standard form. First and last term are perfect squares, and the square root of these do give you the middle term. So once again, they're reviewing the rule. And I think we did these already, so. Okay, here's a new one. And you might try it as a special technique. Now remember, you always want to see, can you take out a common factor from each term? No. So we know there's going to be an A there and a B there. And our middle sign is going to be negative. So what's the square root of this? 4A. What's the square root of that? 3B. Now, do that special technique. Square this term. It makes that. Multiply these two terms together. You get a negative 12AB. Double it. Negative 24AB. Square this term. Now remember the negative signs included. So it's going to be negative times negative gives you a positive 9b squared. And if you check it during doing that special method, it works. Okay, how about this one? Well, again, we have to see what we can factor out of each term. We know we can take an A out. And let me pause. So again, the first thing you should always do is look to see if there's a common factor. This goes through all of the factoring we've done throughout the various sections of this chapter. And I see we could have taken out a 3a, which we did. So the 3a goes there. And then we're going to try to see if it's a perfect square trinomial. Well, square root of that is going to be 2a. Square root of that is going to be, and again we use that negative sign, a 9. And then 2 times 9 is 18. If you double 18, you get the 36. So there's the factorization. And it checks. Okay, the difference of perfect squares, a little background on this. We said if we had A plus B, and it was multiplied by the same terms, but different sign between them, we say the sum and difference of the same terms, the product, that was going to give you, as we FOIL it, a squared. The middle terms canceled out, and b squared. This is the difference of perfect squares, which is what is mentioned here. Now, we also told you that these factors are called conjugates. So we often say that the difference of perfect squares factors into their conjugates. So again, this is like a kind of a cool thing that we can use to make our work a little easier. So again, both terms must be perfect squares. There are some examples, and a negative sign between them. All right, let's go on. And there's what I just showed you. So as we look at them, these are perfect squares, these are perfect squares, these are perfect squares. Now this one, as we look at it, doesn't look like a perfect square. But notice we can do some factoring there, and then it will become one. All right, so let's do these. I'll put them right up here. These are sort of easy to do. We just put two sets of parentheses and then x plus 3, x minus 3. The difference of perfect squares factors into their conjugates. Y plus 4w, y minus 4w. Difference of perfect squares factors into its conjugates. Let's see if I get my pen working properly here. There we go. 5 plus 6a to the 6th, 5 minus 6a to the 6th. And then you can just FOIL it if you'd like to double check, but that is correct. Now here we're going to factor out a 2x squared. This gives me then a 49 here, which is a perfect square. And this gives me 4x to the 6th, which is also a perfect square. So we set it up, 2x squared into their conjugates now. 7 plus 2x to the 3rd, 7 minus 2x to the 3rd. And if we FOIL it, we get this, and if we multiply it by that, we get this. Remember, you can always go back and look at it again. Conjugates, conjugates, and I guess they didn't do the other ones. Okay, we did them all. All right, now they're giving us some that are a little more challenging, because here we see 4 terms, and you might think, well, I want to factor this by grouping. This is what we had as a skill earlier, factoring by grouping. So what can we, let's see, I think seems like we missed a slide there. So we're going to do some factoring by grouping. Okay, there we go. So we have 4 terms, and we want to use that technique of factoring by grouping. And again, we look at the first 2, and what can we take out of that? Well, we can take out an x squared, and we get an x plus 6. Now keep in mind, we want to get an x plus 6 out of those second 2 terms. In order to do that, look at it carefully. Both signs are opposite. So we're going to factor out a negative 25. And then we put x plus 6. And then in our other set, and I'll change colors so you see them, we get x squared minus 25. That's this term and this term go into this set of parentheses. Now an interesting thing happens here. What do you find? This is the difference of perfect squares that we will now have to factor into its conjugates. This part stays the same, and we go x plus 5, x minus 5. Now if you multiplied all these binomials together, you would end up with this up here. Okay? And probably what you would do first is FOIL this to get that, then FOIL this or use this method to get that. Notice you could put the x plus 6 first. I usually put it over here. And there's the factorization. All right, now this one is a little bit tricky because as you look at this one, you might think, well, I'm going to factor. Now, as we look at this one's a little bit tricky. So you think you might be able to do it by grouping. It's 4 terms, but that's not the case. What we're looking for here is we're going to put a parenthesis there, and there is a perfect square trinomial. So that's something you have to look carefully at, which will factor into, let's put a parentheses and plus 4. So this is sort of like the difference between perfect squares, where this is A. So watch what happens. A, that's your A, plus Y, and then your A again, minus Y. And that is the factoring. So it's going to be A plus Y, A minus Y. Notice the A's don't change. So if this is A, it's not changing. Okay? There they are, setting it up like we did. Perfect square trinomial. And then the A's do not change. Okay. Now, they're going to ask us to solve some equations in which we have a polynomial that's either the difference of perfect squares or perfect square trinomials. Now, notice if they give us this particular example, In order to solve it algebraically, we have to put it in standard form, and we did this one already. Then use grouping to factor it, which we did. And then once we got the difference of perfect squares, we factored that into its conjugates. Then we take each of these factors, equal it to 0, and these are our solutions: a -6, a -5, and a 5. Those, if you put any of those in here, they make it true. And then one other little note is, how come there are 3 solutions? Well, because this is a equation to the third degree. Yes. Okay. Again, we did the factoring, so we did this part. We just had to equal it to 0 and then get each of our solutions from that. Okay, now you can also use, in some cases, the graphical method. That was finding the zeros, but in the Math 105, we're not featuring that. Okay, and that wraps this up.